Well, howdy, y'all, and welcome to another high-powered episode of the High Voltage Lab Show. I'm your host, Willie Snyder with Nat King Code, joined by my awesome partner in crime, James, the man, King James Stallcup, CEO of the Volt Online Academy and creator of this podcast. And I just love the myth of the week. Every week, I always have everyone on the job site asking me, hey, Willie, is that even legal? And I'm like, oh, dude, watch the podcast, find out. In my opinion, the lug, it doesn't look like it's rated for that or listed or identified or anything. So I couldn't find anything on it. It was just a picture I ran across, and I thought, you know what, I'm gonna throw it in there.
Sure.
It's pretty fun. Oh, welcome in, David Englehart.
Yeah, been a wild week, hadn't it? Man, been a lot going on. I noticed right before we come on, I saw that dummies went was it 21-8?
Oh yeah, dude.
Wow.
We're almost 22. Yeah, it's
Right,
crazy.
man.
Yeah, David's asking about the death match, and we're working on it.
November is
Okay.
when we're going to do. We're finishing up right now for the code changes. We're going, we're checking everything, dotting all of our I's, crossing our T's, and we're, it's probably going to be right in October when we're going to release it, probably second week it's looking like.
Nice. Well, and it's so much fun. Like I've been taking like a bunch of practice tests because I'm getting ready to take my NISAT too. And so it's pretty cool. I just been studying and trying to check out a bunch of the fire codes, and it's really cool because that the fire saping is one of the STI fire saping is one of the most misunderstood codes out there. And I've had like inspectors like, oh, well, you got to use these special toggle bolts. I'm like, no, you don't. It's just, I mean, unless you're penetrating the wall on the other side, but
Right.
It's just like they don't realize that if you're only penetrating that one side. And then it's funny because I had times before where we're in multifamily where they're like, oh, you have to putty pack those single gang boxes. I'm like, they say 2-hour rated right on them.
Mm-hmm.
So it's just funny to get in those arguments. And then guys are like, oh, you have to have certain color ceiling wires for your fire alarm. I'm like, no, you don't.
No,
It's chapter 3 wiring method.
It's good to go through everything, and talk about all these different topics and everything. And it's just that's why we do the podcast. And
and it's pretty cool too, because like a lot of my apprentices are like asking me all kinds of questions, and I get different questions all the time. One of the questions we had from one of the viewers this week was is there a limit of how many pipes you can take out of a J box, and stuff like that, you know what I mean? And it's like, well, that all depends on how many
openings you have.
Yeah. I mean, so I was like, you could have every single hole in the whole box filled up with conduits as long as you only got one circuit going through each one,
So it comes down to the fills, what you got to worry about inside the box. It's not having conduits you have coming into it.
Yeah, so I referred him over to 214 to calculate his box fill and stuff. And that's the thing that's funny about some of this stuff. Like we were doing one, and the guy's sitting there like, oh, well, these guys are messing up because they're not putting ground pigtails in here. And I'm like, pass it straight through the box. Does it need one?
Yeah.
And stuff like that. Yeah. And so stuff like that's kind of cool with a lot of these myths where people are sitting there interpreting something a certain way. And then, you know what I mean? You're like, well, you go read the language and that's exactly what it says,
It's just like when we were doing, I was doing the journeyman prep, and some of them didn't know about where you had over 4 conductors taking it at a quarter. They were like, when that come in? I said, last cycle, and having to show how to do that calculation for anything that was over 4 conductors.
Yeah, and that's the thing too that I was going to tell David is we're going to try to incorporate 2023 stuff into the death match. So that would be kind of cool if we could get the latest and greatest in there and then kind of up the ante. So you have to kind of have that newer code book to try to compete a little bit. So
Well, what I'm going to do with that is I'm going to have 4 additional questions for the 2023.
nice,
It's I guess extra credit, you know,
nice.
and sort of set it up that way, but it'll be on 2020. So,
Okay. Well, I'll be packing my link, so if I got my link, then I should be all right. And I really appreciate sharing the NEC for Dummies group is awesome, and I really appreciate NEC Live sharing all their feeds every week, and it's really been awesome. They just had the Western Sections meeting, and so that was pretty awesome to get involved in that, throw some questions up in there, and so I'll be having that coming up soon where I'm going to be throwing in some questions from the Western Section meeting and different stuff like that. I really like the Western Section series. They have a little Q&A code thing, and so I'll be throwing it in there. But
well, I have for the topic this week separate drive systems, but we're probably going to do it in 2 parts and do the next
okay,
part next week because there's
that's fine.
there's a lot to cover there. I have 20 illustrations. It'll be a long night if I go through all 20 of them, but I'll have it.
Yeah.
I've already completed the full thing, and that particular portion, I upgraded all the illustrations and everything
Oh, nice.
with all the new, like we had a new transfer switch and things like that. I also
Nice.
have one that shows a new type generator, where they come as one unit. And we've been doing a lot of major upgrades here, trying to get ready for the next cycle. Yeah, I heard him say 214 too. I just didn't say anything. You said
I said 314.
no. You said 214. David
Oh,
tried.
all right.
I just let it go. I was like, you kept going. I just like, I ain't gonna worry about it.
Okay. All right. Thanks a lot. Appreciate you, David. Yeah, I didn't realize I messed that up. But the show's gonna get really long if we don't run the myth.
Yep. You ready for this?
Let's do it.
All right. Here we go.
It's time for Myth of the Week.
All right. Thank you, everyone, for all the participation this week in Myth of the Week. It was really awesome. I'm hitting like really right about 50,000 every week on all the groups. NEC for Dummies hit 10,000, which was really awesome. That was really awesome to see a group of 20,000 get at 50% participation in our Myth of the Week. So
I will tell you, I'm going to have a different graphic for this next week. This is just one that I was using for topic of the week, but it'll be a little bit different. And
okay.
what I did here is everything you see here on the left hand, that goes with like my background here, where you got the arrows. That's the myth of the week, and then the one below it's topic and tool of the week, and then the changes. So it lets everybody know which one we're covering. I try to do something different I've never seen anybody do before.
Oh yeah, that's cool. Awesome. Well, so this is kind of a funny little myth because where it comes from is a lot of the home inspectors, they fail a lot of installs for having 2 hot conductors or 2 ungrounded conductors underneath on a breaker. And there are breakers that are listed for that, and most notably the square Ds. I don't think there's any that aren't. But then in all actuality, you would have to have a breaker that, you would have to have circuits that are, say, 10 amp non-continuous loads or whatever you may have, but you wouldn't just put 2 20 amp loads on that 20 amp breaker. You'd have to have a load that the breaker could handle.
Sure.
If you're going to do that. This was a picture I found off the internet, and I thought it was pretty funny when I saw it because I was like, I don't think that's legit. But I mean, it could be, it just to me looked like, yeah, I don't think that's going to fly because what's going to happen is, especially if that's stranded conductors, you're not going to get a really good connection on those parallel conductors. And to me, I just thought, that's not right. But it could be listed and labeled or whatever for those conductors. But you look at the one on the right, it has all the information listed there. It tells you can put two of any size as long as you are, typically when you're parallel, and it's going to be the same size conductor. But that wouldn't really prohibit you from using a different size, like if you were trying to do something else. I mean, it's kind of a gray area, I guess, that it's usually when I do it, they're equal size conductors. But if it's a listed lug that gives you that wire range, I don't see why you couldn't, if you're doing like a tap for something, why you couldn't use that. And so we use that pretty good out in the gas and oil field. We use like pretty much common sense when we go and look at these. We look at the listing, the labeling. And so the one on the left, I'm saying, is not legit. The myth this week, all of our participants, we got like a 99.9%. Like, I think there was like maybe one person that said false, but everyone else said true. And the correct answer was true, that you can use two conductors per terminal if it's listed for that use. And so
Sure.
I thought,
when I look at it, one way that you can tell is looking at the inside where you're going to make the termination there, because you'll notice ones that are not, they're just completely round. The ones that allow it, they actually have like a half circle up above and below, so they'll set in there and compress properly.
yeah, and I do agree with you, David. I would say, as a general rule, the conductors do have to be the same size. I mean, I don't think it's going to make a really good connection. To me, I have actually done that before, where I had two different size conductors in a lug of this, but we went and we looked at it, and it basically didn't say anything that they had to be the same size. What we were doing was, we had a small section and we had to tap off with some number sixes as tap conductors. And there was nothing in there that said we couldn't do that. And we went over it with the engineer and everything. The engineer checked it out. He was like, yeah, you're good. He's like, just get the torque on there, make sure that you have the correct torque, and make sure that, those conductors don't come pulling out of there when you're done. But, typically I do a lot of fire alarm, and in the fire alarm, we use two conductors per terminal almost daily, and there's really nothing wrong with it. A lot of guys will sit there and say, when you come into that your fire alarm nodes, that you should have like one conductor per terminal. And then you get into some of these fire alarm panels, and you have that class 1 wiring coming in one compartment, and then you have to exit that compartment to go somewhere else. That you're have limited space to do that. So that's why this is kind of an important myth. And, a lot of people were like, this is stupid. This is common sense. This is easy. And I'm like, not for everyone. So that's why we wanted to do it, and, so like I say, the one on the left, I think personally is a violation of 110.3B. Just
Yeah, I don't
because.
think that is listed, and the reason, or it's identified for that, because I'm looking at the inside of it, and you don't see where it has that little offset in it to where those conductors would seat inside
Yeah.
there properly.
And I really liked Chris Boland's comments. He's a Colorado guy, one of my buddies, and he said, you know what? If it says that it's listed for that, then you can do that.
Yeah,
So I mean, he had a good point with that. That nothing I could find says that that's illegal. Personally, if you ask me, that's just a standard double barrel lug. And that's even funny. I think what I thought it was funny was, you could just increase the conductor size and just do singles on that. There's no
hmm
reason to parallel it. So that's why I thought it was kind of a comical picture. And I decided to run it for this week's myth of the week. And so the myth is confirmed. that you can use 2 conductors per terminal if everything is, if you just do a little reading and follow the manufacturer's instructions.
Sure. Most of them I've seen, though, like I said, the inside of that lug, it's got a place set in there for those 2 conductors to seat properly.
Right.
Those are the ones that I've seen.
Yeah. And I could see where David's coming from, that if you have like say like a 2-aught on one and then you tried like a number 6, how they wouldn't really seat that good even if they are listed for paralleled conductors. So
Mhm.
typically what I've seen, those conductors are the same size, but like I say, in that condition that we had out in the gas and oil patch, that was the only way we had to do it. It was my idea actually, because I was like, well, you got this, lug that's listed for parallel conductors. Like, can we just parallel the number 6 up there? And they went and looked at it and they're like, yeah, that's the only way you could do it. And
Mhm.
so we went and we torqued it real good and got all our listed torquing marks. And we have out there, they do torque witness. So we actually have to sit there and torque it with the guy witnessing us torque it,
Right.
and then we sign off on the torque values, and then we measure everything, and it's crazy out there. Like there's nothing that's gonna really mess up out there in the patch, because they're just so thorough when it comes to torquing and using the right materials, listing and labeling, all that stuff's really scrutinized out there.
Sure. All right. Cool.
Yeah.
Another
So
one busted, baby.
yeah, appreciate everyone joining this week. It was really awesome, and like I say, I can't believe that Dummies, it was like 50% participation on the myth of the week. Like that just blew me away. I couldn't believe it. I think I was at like 9,500 out of
Yeah.
out of a group of 2,100.
Let me move that out. I forgot to load all these slide presentations. I was at the
Yeah,
last minute again today, man. I'm telling you, we've been swamped around here. God dang, man.
yeah, I feel you. It's all good, I mean, I know that whatever you've been doing is awesome, man. You like your graphics, like behind you, it's really looking awesome, and I've been trying to like record some more sweet metal, like
Sure.
because we need to make America metal again, and we do that by just recording a whole bunch of metal, but
Well, I can tell you all the for 2023, all the new illustrations that are coming out, man, they are fantastic. It's the design. We'll update the design book, and not all the new illustrations are going to be in there. The but I think what they're going to do, they'll be in the online courses, and then I think after they get through the first print, then they're going to put the new illustrations in for the second, because there's about 1,300 of those that we have to upgrade. So, you're talking probably a year and a half of hard work to do all these major upgrades.
yeah, and that's a good point. That it's hard to tell by that picture. Could we go back to that picture real quick?
You talking about, oh, I see what he's asking. Yeah. Okay.
So if you go back to the picture of the myth of the week, yeah. So if that's 1-aught, that's okay. But if it's not, which it doesn't look like it looks like number 6 to me. But
That's a
yeah,
number 6 or number 4.
that's a good point. I appreciate you bringing that up. And like of course it's really awesome. And yeah, David Englehart's right. The parallel rules. This
Yeah, that is correct. That's over in 310.10G where you get into your parallel conductors.
right, absolutely.
And when you do that, they got to be the same everything basically. It goes through a whole list there, and it can't be smaller than 1 aught. He's 100% correct.
Absolutely. Yeah, and it's hard to say, like its looks are deceiving on that. I've had times before where I tell somebody, "Oh, dude, that's like number 10 or something." And then they're like, "No, dude, that's 500s, Like when you're looking at the picture, you can't really tell like that scale. And I just thought it was a funny picture. I just thought I was like, there's no way that's right.
Yeah, no worries. All right. Well, you want to do topic of the week? I got a sweet presentation.
All right,
All
separately
right,
derived systems. Let's go.
all right, let's show it. All right.
Yeah, definitely approve of that song. I like
Well, I
that
hope
one.
everybody likes the newer presentations. I think they're a
Yeah,
little bit cleaner and not as darker. It's easier to see
that's
everything
cool.
a little bit easier. But
Nice.
what we're going to look at, we're going to get in talking about separately derived systems. It's just a basic illustration, and when you go into our publication, we just explain here that you have low voltage, high voltage feeders, and that they're sometimes installed. We'll tell you like 4 to 4 for like when you're in a high rise building, and where you have the transformers installed on each floor to reduce the voltage. Say it could be to 120, 240, or 120, 208 volts. And that, of course, is for your general lighting and receptacle loads in these large building type applications.
So that looks like a step down transformer, correct?
Yes, yes.
Okay.
And well, you can tell because the top portion, we go brown, orange, yellow. That's usually 48277.
Right.
And then black, red, blue, and white's a 120, 208, or 120, 240. That's
Gotcha.
just a basic concept most people install by. And
Okay.
you know, since 1978 NEC, they put in here that this may be installed either at the transformer or at the load served, where it is going to be connected. And this is supplied from that secondary side. And what you would go when you're looking at those conductors on the secondary side, you would look at 240.21 C2 and C3, and then you also would look at 240.92 C1 through C3. And
Right.
I'm not going to get into all that. I'll do that a later time where we'll go in and look at sizing just secondary conductors and doing tap conductors and explain the difference between one being a tap and the other one just being secondary conductors. And that's where you go in and you look at 24021B and 24021C.
Right.
And so
Yeah,
what
I don't know, man. I don't know what you're using to bend those 90s, man, but that looks a little tight, man.
it's just it's easier for us to do it that way
Right.
because uh, we could put little turns in it and stuff, but um, it sometimes we get a lot of stuff on the illustration, and it's easier to keep them square. That way we can get certain information and tighten it in better.
You
It's
should throw like LLs and LRs in there.
yeah. Well, I'm not getting that deep into it.
Dude, it's not that hard. Come on,
Trust
man.
me, it's hard just to do what we're doing here. One of the things we spent, God, I don't even know how many hours, but there was tons of hours that were put in on doing these panel boards.
Right.
Uh, uh, I mean, God, there was a lot of time, and they tried to make. We're trying. You'll see later. We'll have like transformer inside what it looks like, but
Okay.
for this type of illustration, it was better to do it this way because we wanted to sort of show where the terminations and stuff, like you came into a delta and a Y, so people would understand it. It's
Right.
hard to show that in a transformer.
Right.
So
And just for argument's sakes, you should throw like a support in that conduit. So.
yeah, well, I'm not going to get that in depth on it.
All right.
The only time we do that is when we're dealing with installation of wiring methods and we're
Okay.
trying to show, and then we call out supporting and all that. But for stuff like
Gotcha.
this is just general, so you understand what you're looking at. Like in this illustration, one of the newer things we did, you'll notice most everything I see out there, they've got like a little box, and they'll point to it and say this is transfer switch and stuff. What we're doing now is we literally have uh, uh, a transfer switch that we've drawn here. And this has the readout, digital readouts, everything on it. And then we also took and did an on-site type generator like you would see in different uh, places. So from what I'm understanding, we're going to have three different type of generators that you can look at. And
Okay.
that's going to deal with our generator transform motor compressor. And it's based on KW, the different types that you would have. So
Dude, I'm loving the new illustrations. Like they look awesome, man. I mean,
yeah.
I'm not at any means dissing you or anything.
Oh, thanks. They've taken like the illustration you saw before with the panel board. You'll see the new panel board. Sometimes we show everything covered up. Sometimes they're open where we're wanting to show connections. This is just a general diagram that's just sort of letting you know you have a separate drive system, such as we're looking here, a generator. And
Yeah.
we tell you that generator shall not be grounded where the transfer equipment does not switch the ground and neutral conductor, and where the
Right.
ground and neutral conductor is solidly interconnected to the service supplied
Yeah, dude,
ground
that's
and
an
neutral
important
conductor.
one, man. A lot of people don't know that one.
Mhm. And even when I was at NFPA and I was teaching with them, we would go out and we would talk about the transfer switches and everything, and whether it was switching the neutral or not. And that, if it's switching, of course, you had a 4-pole type, and if you wasn't, then it was a 3-pole type. And
Right.
we basically went through that and determining if it was considered a separate drive system or not. And that's what we're going to get into as we look at all these illustrations.
Dude, hit me up. I got a really cool transfer switch drawing. And it was really funny because, or not a drawing, it's a picture.
Uh-huh.
But we were out in the gas and oil plant. We had um, a 208 volt 3-phase transfer switch that switched to neutral.
Hmm.
And the crew that went out there and made it up thought it was high voltage.
Hmm.
So they made it all high voltage and it was actually low voltage how they marked it.
Mm.
And so we were giving them a hard time. We're like, okay, so let's get this right straight. The 208 volts comes out of the transformer. When it comes into the building, it turns into 480. Is that how it works? And we were just giving them a hard time, and they ended up going to redoing it and stuff. It was no big deal, but it was still really funny to open it up. And I took a picture of it, but I'll have to send it to you. It was really funny because it was all labeled high voltage, but it was actually 208 3-phase.
I was looking at that. I was thinking, we got a makeup box there. I wonder if them guys over there are considering that an outlet.
Eh? I don't know. It's a point on the wiring system. Feeding utilization equipment. I'll tell you what. Right now, an Ansel control cabinet is not a kitchen outlet.
Well, I agree with that. You ain't gonna get no arguments from here.
Prove that one.
Now, this is where we're going to get into 250/30A1 and B. And basically, what I like to say, when you look at 250/30A, that's where it gets in and it talks about grounded systems. And it's going to tell you that when you have a separate drive system, it's required to comply with what? And there's going to be a lot of listings there of headings that we're going to cover as we go through this. And you're going to have the system bonding jumper, the supply side bonding jumper, your grounded conductor, your grounding electrode, also your grounding electrode conductor. And it doesn't matter because we're going to discuss different ones. We're going to talk about a single separate drive system, and also where we have multiple drive systems. And then, of course, you get into the installation and bonding.
Hey,
Now,
so question for you. One of my apprentices asked me this one time.
okay.
So could you, like in this case, could you take the XO jumper to ground out and just do an XO and just put the green screw at the panel?
Yeah, we can. Well, yeah, you can do that. And what you're going to see if you look in this illustration, right in the pipe, we say or. Do you see that?
Oh, okay. I see what you're talking about. Okay.
And that's what I'm saying. This one particular illustration sets up for all the other stuff we're going to do, and we're even going to talk about the exceptions and everything. We're going to go through it all. That's why I'm saying it's going to take us 2 sessions to go through this
Okay.
because there's
That's
a
cool.
lot of information to look at. And we also tell you if you look at that note 3 there, we talked to you about the Transformer XO is considered the neutral point per where Article 100. And
Okay.
that's why we have these notes in here to help explain all this. And that's why in this particular illustration, right there in the conduit, I put or, because there's options here we're going to discuss later on. This is just like an intro to get us going in the right direction.
Okay. Yeah, I didn't notice that. I thought it was a support because that's technically a nipple. So I
Yeah,
thought you were just throwing a support in there.
yeah, and yeah, it's and I left out the SUPP and the T. So I get it. That's funny as hell there. I like that. Okay, now the first thing you're going to look at when, as I was saying in the grounded systems, in this particular one, we're going to talk about the system bonding jumper, and that's going to be in 250.30A1. And what it's going to say there is that the system bonding jumper, which of course is unspliced, it's going to tell you it shall be designed and installed, and it's going to be based on what? The ungrounded phase conductor supplying the panel board. That could be the switch or other equipment, which is connected from where? The secondary side of that transformer. And
Right.
it's going to be sized per 250.28D1 and 250.102C1. And you'll remember Dad sort of gave some good information about C1 and how it got started and all that.
Yeah.
And it was basically
Yeah.
a replica of 250.66.
Yeah, because that was the 187 on circular mills, right?
That's right. And then,
Okay.
and that's actually what 250.102C1 was. And, but they made it table two, or at that time is 250-94. And now they went back, and that's what he was trying to say when he was doing that course. Table 250.102C1 was essentially based on that 189 multiplier based on the overcurrent protection device to get your circular mill to size that those conductors that were in that table.
Right. And
Okay.
that meant a lot to see it that way because it almost gave that direct correlation between the overcurrent device and then the service entrance not having an overcurrent device.
Sure.
I really like that.
And that's why it was based on all that. And then they did the testing and stuff for all your different electrodes. And that's why some were moved from being made electrodes to not made electrodes. And then from there, that's why they said the size had to be at least a certain size. And if you went above that, it had to be engineered. And the reason that that is because you get larger conductors and you connect it to another type electrode and it's a smaller electrode, then you get gaps in there. And
Right.
those gaps can break apart. And that was testing that was done. And that's why they said it had to be at least a number four. It didn't need to be larger than number
Right.
four. Okay.
And that always means a lot to me when you get into some of these arguments because like what are you really arguing? Like you're stubbing all these electrodes out at the service. So why are you sitting there going I could put like 6 inches of number 8 in there, you know what I mean? Like why would you do that? Like who
Right.
cares? Like what would be I don't see the application of stubbing out all your electrodes at the service and just tying them all together.
Hmm.
It's like the stupidest thing to say, oh, well, we could jumper a number 8 halfway across the building. And like to me, if somebody did that and you're an inspector, you're gonna be like, nah, you gotta redo that.
Hmm.
You gotta do that right. Like
Well,
you can't stub your Uper out on the other side of the building and then run a number 8 all the way across the building. And I was like, that's the dumbest thing ever. Like, dude, if an inspector came up and saw somebody like stub the Uper ground like the wrong direction out of the building, and then like, hey, can we run a number 8 over there just because we have 150 amp service? They'd be like, dude, do it right, brother.
yeah.
It's not that hard.
There's reasons that certain sizes were selected and why they were very specific on it.
Yeah, and you
And
posted that where it said a number 8 or a number 6 was not sufficient.
that's right. And that was, and the interesting part about that, the the guy that submitted it was actually wanting to do exactly what some of them are saying you can do, and they told him no, it's not, it's considered to be too small.
Right.
And the reason it was considered to be too small was based off the testing that was done.
Well, and I
So,
really love it, like, and that's what we really love about this show is that we can actually show these public inputs and show like, hey, why would code making panel 5 reject this public input if you're allowed to do it?
yeah. Well, my whole argument on it is if what they're saying is true, then we just need to get rid of 250.66A through C because it serves no purpose at all.
Yeah, I
I
agree.
mean, it makes no sense. And,
I agree.
what we try to do is set everything up based on substantiations and testing and things that was done. It's like I said, I sort of made a joke about it, but I said, did the ground just magically change somehow due to global warming or something? you know, the ground that you walk on hadn't changed. And so
Yeah,
therefore the testing's not going to change.
and actually, Mr. Uper actually was keeping stuff from blowing up with a Uper ground. So,
Sure.
you know what I mean? Like, that's where that came from.
All right, and I'll tell you another good one, and I'll do this. I'll do it sometime, but I'm going to do one where I go in and talk about the different electrodes and everything. But I also want to show we in our design book uh, we have a lot of design tips and things like that. Well, one of our design tips that we show a table that's in the illustration, and it's recommended by the Metal Water Piping Manufacturers Association, and they recommend there's only certain sizes that they permit to be connected to their cold water pipe. And when you see the sizes that they say you shouldn't connect to it, that'll change your mind on if you want to use a cold water pipe or not. You
Right.
know, I mean, it's very interesting, and but it's not something the code recognizes, but it's something that's out there. It's additional information, and when we give all these different concepts and information, it's made and based off testing that somebody's done.
Well, and the thing that I thought was awesome, we had 4 weeks in a row. We had Mark Candles on, we had Crystal Hunter on, we had Kevin Muller on, we had all together like 4 different guests, and
Hmm.
every single guest held up your dad's publication.
Sure. Matter of fact, I talked to him today, and he's going to confirm it with me. But we're looking at October 20th. We're going to have Mike Barr on, and he's from the utility side,
Okay.
and he's got a mock up he's going to show, and we're going to have him on once a month, talking about the utility as its direct relationship with the building or structure, let's say. And
Nice.
he's going to cover, and he's got a really good known safety just for them guys, and sort of showing the direct correlation that what they do compared to what we do in the NEC. So I thought that'd be very interesting for our
Yeah,
audience to hear.
and actually, you got two separately derived systems there. You have the utility
Hmm.
derived system, and you have what we're doing the step down to our separately derived system.
Sure, that's right.
So that's depending on your service point.
All right, and let me get back on this. All right,
All
now,
right.
so when I'm looking at this, and I get in and I start looking at sizing the system bonding jumper, they're going to tell you that it's going to be size here, and we'll be looking at, as an example, we'll be looking at table 250.102C, one note one, and it's going to say this is based on the ungrounded phase conductors, of course, up to 1100 kc mil copper and 1750 kc mil for aluminum. And once you get above that size, then it's going to tell you that the system bonding jumper shall be sized at least 12.5% or 0.125 of the circular mill area of the largest ungrounded phase conductor where these service conductors are larger than the 1100 kc mil copper or 1750 kc mil aluminum. So therefore, the system bonding jumper shall be installed and connected at any single point on that separately derived system, and this would be from the source of the first disconnecting means or overcurrent protection device. And if those ungrounded phase conductors are larger than that 1100 or 1750 for aluminum, then the system bonding jumper at that point will normally be larger than what? The grounding electrode conductor.
Right.
Okay. Now, I'll give you an example. I'll just make a problem up. It's not in this illustration. But let's say that you had a copper uh, 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 system bonding jumper, and we want to know what size is required to bond and ground the secondary of a separately derived system. And let's say it has 4 3/0 THW and copper conductors connected to its secondary.
Mhm.
Well, when you go look at 250 table 250 102C1 and you pick up the 3/0 conductor, it's going to tell you the size of that bonding jumper is going to be required to be a number 4. Okay.
Okay.
Now, if I turn around and let's say I'm going to parallel at this point, and let's say I've got a 3-phase 4-wire service, and let's say I have 4 600 kc mil THW and copper conductors per phase, what size system bonding jumper would be required to bond and ground that separately derived system at that point? Well, what you
3
would do,
I'm just
you would
kidding.
go to step 1.
Uh-huh.
And we said if you're over 1100 kc mil, well, we want to know what the kc mil is here. So I would just take the 600 kc mil times 4. That's pretty easy. That's going to give you 2400 circular mil.
Uh-huh.
Then I look at 250.30A1, which said anything over 1100, I take it what? 12.5%.
Yeah.
So I would take that 2400 kc mil at 12.5% or 0.125, and that's going to give you 300 kc mil will be required for that system bonding jumper. Okay.
Right. Okay.
That's how easy it is to do the calculations. And I'll have some of these later going through all this, but I'm just sort of making problems up on top of my head so you understand where we're going with it.
Yeah, we had one that was similar to that. And when I was doing like a journeyman renewal, probably back in like the early 2000s, and I to me it didn't really make sense because they said that the bonding jumper was gonna have to be 600 MCM,
Mm-hmm.
and I'm just like, they don't make 600 MCM, ground bushings, and like you'd have to just be like, there's no way you could do that. But uh, I get the point of the math and everything, and I thought the biggest part of that was that you're not going to be running 6 parallel runs, through steel conduit, and I think that was the big thing about the bond bushings, because they were asking what size conductor you would need to go through the bond bushings.
Mm-hmm.
And I was like, there's no way that they're going to have service entrance coming through steel conduit. You know what I mean? It was far-fetched, but
Mm-hmm. Yeah. That's why we go through all this so people
Mhm.
can understand exactly what we're doing here. Now,
Yeah.
if I'm looking at that illustration as an example, where that system bonding jumper is installed at the source. Okay, so the source is going to be where the transformer, right?
Right.
Then they're going to tell you there the system bonding jumper that we size there shall connect the grounded neutral conductor to the supply side bonding jumper and all the normally non-current carrying parts of what? The metal enclosure. So it's all done there. Now, where the system bonding jumper, where I'm going down the panel board, is installed at the first disconnecting means. Then they
Mhm.
tell you that the system bonding jumper at that point shall connect the grounded neutral conductor to the supply side bonding jumper, the disconnecting means enclosure,
Ah,
and also the equipment grounding conductors.
all
But
right.
there's one thing you got to be careful of here. in between that transformer and that panel board, you wouldn't want to have a metal conduit between that because that creates a parallel path. You see what I'm saying?
Yeah,
So
okay,
that
I
would have
got
to
you.
be PVC there.
Ah, okay.
All right.
So now you're supporting PVC.
Yeah, if I
No,
have to.
I'm just kidding.
But you see where we're going with it? It
Yeah.
it depends on the setup and how it is. And you can go and look in our design book and we explain this whole layout system and everything and what them notes are about as it relates to that. And then we'll also explain where you need to go in other parts of illustrations where the calculation would apply, whether you're at the source or the disconnecting things.
So if you have a metallic raceway that's going from your transformer to your panel, then
It'd
you're
be
gonna
done
want
at the source.
okay, and that source being the transformer, right?
That's right. And
Okay.
that's why we have or there because we're showing one at the transform, one at the panel board.
And if it's PVC, then it's support too.
Yeah, support too.
No, I'm just kidding.
All right. Now, this is another one where you get in, and this is sort of where I was talking about seeing how we redid and did the interior of transformers. And
Uh-huh.
you'll see us show some of the transformers this way. It depends if we're showing a connection or not. This is just one where we're showing a double fed or basically double ended type. And these are systems that are installed in accordance with 450.6. And this is where you have a single system bonding jumper connection to the point of that grounded circuit conductors from each power source. And that when you go over and look, it shall be permitted at this point for the separately derived systems that are dual double ended in a common enclosure, which employ what? A secondary tie.
So in this kind of situation, what would you use this application for?
It's where you got you're setting up. We have in our transform book, and we also have in our design book where we go in and look at 450.6 and get in where you have transformers and you're creating a bank and you got radial grounds and stuff. That's what this is getting into.
Okay. So you would need to like size all your conductors off 450, right?
No, you still set the system bonding jumper and everything up here per exception one, but 450.6 is where they're getting in and they're talking about these type of transformers where you create these radial grounds and stuff.
Okay. I was so glad I didn't say 250. David would have to correct me again.
Yeah, no worries.
Yeah.
All right, now this is where you have additional system bonding jumper, and what they tell you here that you can have an additional system bonding jumper connection. Basically, that means there's going to be more than one. And this is permitted to be made. And let's say I will say this. It's only permitted to be made, only we're doing so will not create what? A parallel path.
Yeah. 250.6.
Yeah. And that parallel path is for the grounded circuit conductor. And when this additional system bonding jumper shall not be permitted at this point to be smaller than the other system bonding jumper, but it shall not be required to be larger than what? The ungrounded phase conductors.
Yep.
So basically, what it's stating here is that the system bonding jumper shall not be required between enclosures for installations that comply with that type of installation.
Wow.
Okay.
Okay.
And that's why we went ahead and put this in here because it is recognized in the exception. But when you look at that, basically what the section is really stating is that there will be no parallel path can be in any way set up to where it can be formed uh, uh, to create this parallel path when you're installing any type of additional system bonding jumper at the equipment you're supplying by a separately derived system. So the
Okay.
basic rule requires a system. Think of it this way: the basic rule when we're looking at this requires a system bonding jumper and the grounding electroconductor connection to that grounded system conductor to be made at the same point.
Right.
All this is an exception to the rule, but only for cases where there would not be a parallel path, such as using a non-metallic PVC conduit that's run back to the transformer source, and it's located to not share conductive contact with what common structural elements or equipment grounding conductors.
Right. Which PVC wouldn't do that
That's
anyway.
right. That's basically what we're trying to say here.
I
Okay.
mean, and would the same apply for like Carplex? Like if you use Carplex and like it's not a metallic seal type.
Yeah, anything that's non-metallic's fine. You just
Okay.
don't want metal pass back to where you can create that parallel path. That's all they're telling you here.
Okay. All
And
right.
that's what that additional system bonding jumper is about.
I got you.
Okay. Now, the exception 3, what this is going to get into is your class 1, 2, or 3 circuits. And basically, what it's going to tell you is the system bonding jumper shall be sized where it's not smaller than the derived uh, ungrounded phase conductors, and it tells you it shall not be smaller than number what? A number 14 copper or number 12 aluminum for any type of system that supplies a class 1, 2, or 3 circuit, and it's derived from a transformer that is not rated more than what? 1,000 amperes. Okay. So basically, what type of installation would you see this? Maybe like a doorbell or something like that. And they're basically saying the equipment ground serves that function, doesn't it?
Oh yeah. Okay.
That's all they're saying there.
As long as it doesn't have leakage current, like
You
we're
know, this
starting
is the
with.
one where I was on NEC Live and you asked me if transformers had to be listed, and I said
Whoa.
it depends what type of
Yeah.
transformer you're talking about.
Yeah, and I think I did mention class 1 transformers
Yeah, and that'd be
because
a listed type device.
I knew class 2 already says listed in the reference.
Sure. All right. Now, the next one you're looking at here is uh, your supply side bonding jumper. And this is where we just got. Now, all of that we just looked at was an A1. Okay. By the time I finish this, we're going to go all the way through A6. I'm probably going to do all the way through 3 tonight, and then 4, 5, and 6 we'll do next week.
Okay.
All right. Now, this is a supply side bonding jumper in A2. And what they tell you here is that uh, the way we'll label this in a lot of ours, you'll see in the illustration there, this is where I have a supply side bonding jumper going down to the panel board, and we label that as S-SBJ. Okay.
Okay.
And we tell you here a supply side bonding jumper shall be installed with the circuit conductors from the source enclosure to the first disconnecting means where the source of a separate derived system and that first disconnecting means, which is at that panel board, are located in separate enclosures. And then we tell you the supply side bonding jumper shall not be required to be larger than ungrounded phase conductors. Now, I want to point one thing out there. In order to have a supply side bonding jumper going down to that panel board, if you uh, start looking at this, you have to make sure that that bonding jumper is permitted here to be of a non-flexible metal raceway or of the wire type or bus type based on which requirements. This is what you have to pay attention to.
Okay.
It's a wire type, and if it is a wire type, it has to comply with what? 25102C,
Oh
and
yeah.
that's based on the size of the ungrounded phase conductors. If it's a bus type, then you got to pay attention to the cross-sectional area, not smaller than the supply side bonding jumper of the wire type per what? 25102C. So whichever type you're using here doesn't matter, but you're still going to have everything based on 25102C.
Okay, gotcha.
All
All
right.
right.
And that's why we like to sort of show, depending on how you're setting this up, how you're hooking it up and everything, there's certain rules you need to follow and know the difference between doing uh, uh, a system bonding jumper and a supply side bonding jumper. What is the difference between the two? Okay.
Okay.
Now,
I really like how you put all those code references on there. It's really easy to understand, like all your illustrations.
Well, I've seen a lot of illustrations out there, and I have yet to see any that go through as detailed as this and where all the sections are that you would go to size which type of conductor and calling out exactly which one is which. That,
Right.
like this illustration, there's a lot of detail in that illustration.
Dude, there is. That's awesome.
And the
I like how
reason,
you added like the Y and the delta. Like that's so cool. Like, cause you just like looking inside the transformer.
yeah, and the reason it's we designed that transform that way because we want you to see where it's coming in and where everything's connecting to the bar and everything, and then where the grounding electrode conductor's going, where the supply side bonding jumper's going, where everything is, going to that system.
And the one big thing that I like too is I never knew there's so much stuff that I learned like when we're doing some of this stuff. And it's funny because everyone's like, there's no such thing as a three-phase transformer. You know what I mean? And I'm just like, oh, okay. I mean, I thought that gray box that showed up was a three-phase transformer. No, it's three single-phase transformers enclosed in a gray box.
Right.
And
Yeah.
I didn't know that like until about a year ago or whatever, and I felt like a dummy kind of because I'm like, wow, really? I didn't know that.
Yeah.
So that's why we kind of do this. Like, I'm not above anybody when it comes to knowledge on learning theory and everything else.
Sure. And there's a lot you have to look at, and that's why I thought this would be a good one to do because I've actually had requests to do this one, and I didn't want to do it till I got the illustrations looking pretty sharp,
Yeah.
and because I wanted everybody to really see the colors and everything, and that's one of the things that we're going to do. Soon as I finish the code change book for 2023, get it all on, then I'm going to do the journeyman masters, and then I'm going to do the generator transform motor compressor, all those illustrations. And then the first one we're going to do out of the design book is going to be the grounding. And there's about 100 and shoot, I bet there's around 150 illustrations, I guess, or 30, something like that, just
Right.
for that chapter. And they'll all be done like this, showing you the connections in detail, how to go about looking at these different type of systems.
Yeah, and the one thing that I do like too is how you have the colors kind of shaded good to where it's you can see it good and it's appealing. Like you have the different colors contrasting each other. I do like that. Like the blue with the white
It,
lettering and the green on there. It's cool. I like that.
there was a lot of time and effort spent going through and working on the colors and stuff to get them to show up properly to have that type of colored illustration.
Right. No, it's totally awesome. And I are is your code change book colored?
Yes, it's colored, but I've looked at it. It's not at the detail what you're seeing with the newer ones that are coming out.
Okay.
We didn't have time to draw everything brand new. Now,
Okay.
when the 2026 version comes out, it'll look like this.
Nice. So do you have a release date for your code change book?
We're looking mid October, but by 1st of November for sure.
Okay.
And there's just a lot of we did 230 something changes. If
Wow.
if we were just doing, the top 150, the book would already be out. But when you're
Right.
doing that many changes, it takes a little bit more time, and we had to wait on the Standards Council and everything to come out, and
Oh.
and they just came out and put the code book online on NFPA link, and now we're going back and we're checking the sections to make sure we didn't miss something. And
Okay.
uh, every little thing, I've caught a couple little things here and there where I took and maybe I highlighted something in red that was a change in the text, and they did it a different way from the way I did it. we're making it all match up with the code book right now.
Okay, so and I know I'll probably ask this stupid question every week, but on 210.8F, will there be an exception for AC units in the 2023 language based on the TIA?
We're not even mentioning it.
Okay.
What we're doing is we're basically saying the same thing we did last time. We addressed all the different things they had. Um, you know, the way we sort of look at it is there's a reason it didn't go in, and it's not going to go probably in 2026 either, because there's still the UL standard comes out in 2024. There's no way it's going to be updated for the
Okay.
next code. So you're going to have a compatibility issue there anyway. And plus, I think there's going to be a lot of proposals submitted on some of these definitions and clarifications. And you know, it's sort of like I brought up the other day. You know, they were saying, you're wanting to apply something on the number 6 that was back in the 1971, 75. And I said, but yet you want to apply a definition as far as I've been able to research back in the 1940s that hadn't changed for an
Wow.
outlet, you know?
Well,
So
and it seems a little deceiving to me, a little deceptive, I guess I would say, to sit there and say, okay, well, that applies to anything that you install outdoors.
it doesn't. I don't
And
agree with
and
that.
and to me, it's like, okay, so now everything applies to it. And then it was supposed to be only based on AC units. So how would, how could they do that? Like to me, the only way I could look at it is seems they screwed up, because I don't see how you could sit there and go, oh, no, we didn't mean just AC units. We meant everything based on this definition. And it's like, okay, well, why did you write the definition for individual branch circuit? What was that doing?
Yeah.
Like,
First and foremost, there's a lot of equipment out there you're going to have a lot of compatibility issues with, first and
mhm.
foremost. And second, I do not agree with the statement that's going around that it's a point on the system and you just pick wherever you want to consider the outlet to be, and then them to
Oh,
say,
yeah, it's not a three-dimensional.
yeah, you can't even draw it. That's the stupidest thing. I don't care. I don't care if it upsets people. That's one of the stupidest terminologies I've ever heard. And I can tell you, I'm going to actually submit on the definition of outlet, and I'm going to have an informational note that it just exists, and you can pick out the point where you want that outlet to be. I have a feeling code making panel one, I think, has control of that
Yeah,
definition. They're going
yeah,
to
they
think
do.
what the hell is he talking about? And I'm going
Yeah,
to do full substantiation saying this has been going around, and there's certain people that say that's what a point is, and let them give us substantiation that they don't, if they agree with it or don't agree with it, we're going to find out.
yeah.
So
And
if
that's how
they
we make our determinations on some of this stuff too.
sure
You know what I mean?
if they say it is, hey, I'm cool with it. I'll admit I was wrong. I didn't agree with that. If they say that isn't correct, then I expect the other side to say the same thing.
To me, I guess where I'm irritated with it is like, okay, so we're having compatibility issue with AC units.
Hmm.
Okay, the whole thing was kind of BS to begin with, if you ask me. But okay, so now we're gonna say, well, it's your fault that we got it wrong.
Hmm.
To me, that's where I don't think it's right, because now we have EVSE coming out, and they're saying that's 20 milliamps of leakage current. Why do we have this Class A protection in place now?
Yeah,
And to me, it just gets to the point where it just turns into a boat anchor, and it just gets largely ignored.
sure. All right,
I'll, I'll let you keep going. Sorry, I'm sorry I keep
yeah.
interrupting.
Now, this and we're going to deal with the grounded conductor. Now, one of the things I want to point out, so far we've looked at the system bonding jumper, the supply side bonding jumper, and now we're looking at the grounded conductor. And what you're going to see the same terminology, your size and everything the same. So when I look at the grounded neutral conductor, it tells you it shall be installed with ungrounded phase conductors and shall not be permitted to be smaller than the required, listen to this, grounding electroconductor per what? 250.102C1, but shall not be required to be larger than, of course, the largest ungrounded phase conductor. So therefore, when I go a little further, it tells you that that grounded neutral conductor shall be permitted to be smaller, or shall not be permitted to be smaller than 12.5% of the circular mil of the largest ungrounded phase conductor, larger than 1100 kc mil or 1750 kc mil aluminum. So you're seeing we're applying the exact same requirements here, whether it's the supply side bonding jumper or I'm looking at the grounded conductor. Now, if I go to the next one, this is where you get into the parallel portion of it. And when I'm looking at parallel conductors in 2 or more raceways, it tells you here that the grounded neutral conductor shall be based on the total circular mil of the ungrounded phase conductors when installed in parallel, which of course is in 2 or more raceways. The grounded neutral conductors that are installed in those raceways shall be based on the size of the ungrounded phase conductors in the raceways, but it shall, since it's in parallel, of course, it shall not be smaller than what? 1/0.
Yeah.
Okay. So if I'm looking at this illustration and I'm looking at sizing the grounded neutral conductor that's required in each one of them raceways, I'm going to be looking at table 250.102C1. And if I pick up 3/0 conductors, it's going to tell you it's required to be a number 4. But if I go over and I look at 310.10H1, it tells you the minimum size has to be at least what? A 1/0.
Yep.
Because that's where I pick up all my information for parallel conductors.
Yep.
Okay. Now, as I look at this is where you get in, and this is in 30A3C, and this is where you deal with delta connected systems. And all it's going to tell you here is that the grounded conductor, where you have this three-phase, three-wire delta system here,
Is that an open delta or a closed
that's
delta?
closed,
Okay.
and it tells you it shall have an
Oh, okay.
yeah,
It's a corner grounded, right?
yeah, corner grounded.
Oh, got you.
And
I
it
got you.
tells you it shall have an ampacity not less than what? The ungrounded phase conductors.
Yep.
Okay. It's got to be that size where you have a delta system. And that's what they're going to talk about here, where you're dealing with a separately derived type system and it's delta.
So is that technically a single phase then?
Yes, that's single phase.
Okay, gotcha.
Matter of fact, if you look, you'll see there's only the brown and orange coming in.
Yeah, gotcha.
Okay.
Okay.
Now, and we show that because we're showing you the coils there for that transformer of 480 volt.
Yeah, it's hard to see in the illustration, but it it's just really hard to see how the phase conduct how the ungrounded conductors tap to that breaker.
Yeah. The other one is sort of hard to see, but that's a gray conductor.
Yep.
Okay, for the neutral.
And that could be white too, right?
It could be. It depends on how you set it up. You know, it sort of remind me. I remember I was doing a course, and they were asking me. I'm not going to say who it was, but he had done a class, and he had told them if you took and had two different system voltages at the building, you could have black, red, blue, and white. But if you had another system, you had to have that white, and it had to have a colored stripe. And I said, no, that's not true. If you go over and look at 200.6D, it goes in and it sets that up, and a gray would actually work. Actually, the stripe in it is the second option. And
Right.
and I said, did he give a reason why he said that? And he said, yeah. He said over time you couldn't tell the difference between white and gray. And I said, well, it depends on that conductor and what type of loads in. I said, I've seen red conductors you couldn't tell the difference.
Right.
Over time.
So what you're saying, and see, I know this because I know there was a code change a couple of cycles back where you have to identify the neutral at the service.
Yeah,
And
that's all getting into 200.6 A, B, and D, so where you're going to pick all that up.
Right. So if you have both systems, that you have to have pick a gray for one and a white for the other, right?
Yeah,
You
you have
you can't just pick white for everything, right?
sure you can't because what happens. I'll just make a problem up here to give you an example.
Uh-huh.
Let's say that I come in and I have a 482 77-volt system that comes to the mill, and I'm just going to make something inside the building, not two different power sources coming to the building.
Hmm.
And let's say I come and I've got my panel board and everything there, and I go over run a circuit, and I've got a box there, and then I come over, and then I've got a step down transformer, and I go say to uh, uh, a 120 208-volt system, and then I come out of that panel board, and then not accidentally, but I go into that same junction box where that 480 277 circuit is. You got 277 volts. You got to identify the difference of those neutrals in there.
Right.
And if you got a gray, that's for the 277, and the white's for the 120 208.
Right.
See what I'm saying? So not only is it apparent if you have two different sources come to building, but also if you step it down within the same building.
Right. Hey, I
Okay.
got kind of a funny question for you.
Hmm.
So if you let's just say you have 13.8 kV,
Hmm.
can you color it red, white, blue?
Usually, what's going to happen there is you're going to see them come in. We show in our illustration where they come in with just black conductors because you don't see them color coding at that high of a voltage. That's why they meg them out. But
Hmm.
if the utility, if let's say that you own that system and it comes in, you can identify it however you want.
Okay. Yeah, I we ran into that out at the plant, and I thought that was interesting.
What y'all do? Did you leave it all black or did you color code it?
Well, no, we color coded our phases because it was 7623 phases what it was, I think.
Okay,
So it was 13.8 between phases and then 7620 on each the phases.
right. What color did y'all use?
Red, white, blue.
Red, white, blue. That's fine. Did
Yeah.
you? And that's why I'm saying
And I would say America, but
it. Well, it depends on the facility. I've seen some facilities go. I actually saw one where they did brown, orange, and purple.
yeah.
I mean, you don't. The only thing the code limits on is the neutral conductor and the equipment grounds.
So then it was really crazy too, because then we went red, yellow. It was red, yellow, blue for 4160.
Sure.
So that white meant it was 13.8 and the yellow meant it was 4160.
Right.
But it was weird because I was joking around about it. I was like, "Oh, you're gonna get Jeb Bob Jenkins over there from the uh, Joe's Mobile Home Factory that's gonna come over here and pull up and put in a single phase panel at 13.8." But I just thought it was funny.
Well, that's like I say. If the utility comes in, they're not going to color code that. It's
Yeah.
going to be all black, and that's why I was asking: is it owned by the customer or is it owned by the utility?
So out at the plant, the phasing really mattered. Like it had to be phased correctly. Like so the reason why is because you'd put status on like C phase for some of the motors, and
Hmm.
then some of the other motors you put status on B phase. And so you had to know what status you were selecting for what motor, like depending on its purpose.
Right.
So what they had to do at the control building is they would have to say, okay, well, we got status on our inlet motors because we want to make sure they're running. And then what you have is once the inlet motors start running, it opens like a valve, and
Hmm.
then that goes to like a proof switch. So it won't kick the other motors on until that proof switch clears.
Right.
And then that proof switch clears, that means you're open. Then it'll start the other motors downstream. And then if for some reason that proof switch breaks, it'll shut those motors off.
Sure.
And so there was like a lot of cool stuff going on with controls, but at the same time, you would have status on B phase for the upstream motors and then status on C phase for the downstream motors.
Right.
And then that's how the PLC would see the difference of what's going on.
Sure.
And so if it saw a run status on there and then it didn't see a proof, a completed proof, like they call it a handshake, but if it didn't see a handshake on the proof switch open, then it wouldn't allow the downstream motors to start.
Right.
And so it was kind of a cool system, and it worked really fast. I mean, we were testing it, and I couldn't believe how fast it killed those motors. And those were some powerful motors. I think they're 1,500 horse each.
Oh, okay. Yeah, and that's what I was
crazy.
saying. It just sort of depends on how the system was set up, because usually what will happen is the utilities coming in and it'll all be black conductors, and then from there you had step down and everything, and then you color coded.
We were using tray cable.
Mm-hmm.
So it was pretty interesting. But what they do is the tray cable is all black, but it says 1, 2, and 3.
Okay. Yeah. Yeah.
And so you could use 1 for whatever you want. You could use 2 for whatever you want. You could use 3 for whatever you want. We just wanted to market a phase to keep it consistent on both ends.
Okay.
Straight from the gate.
Oh, good question. That's why I was asking those certain things. It depends on how it was set up, and then from there you make the decision on that color coding.
It's not a grounded conductor. It's number 2.
Okay, I got it. All right, now this next one is impedance grounded systems, and basically you can have a grounded neutral conductor here for an impedance grounded neutral system. But if you're going to do that, then it has to be installed, and you'll look over at 250.36 and also 250.187, and it's going to tell you that it had to be a 3-phase AC system of 480 volts to 1,000 volts. And we show that there in the illustration. And then we tell you, when you're doing this, you got to pay real close attention to make sure that the condition and maintenance and supervision ensure that you have to be qualified. You've got to have continuity of power. You've got to have ground detectors installed on the system line, and the neutral loads are not served. And when you look at that, we give you an example of how much current's going to flow there with a quick calc. So if I had a 482 77 volt system, I'd take that 270 volts, and if you see, I have a high impedance system set up there of 140 ohms resistance. You divide that in there, and it's going to tell you there's about 2 amps that flow if a ground fault did occur.
Right.
And what I didn't have time to finish it. We're also going to put there, where you see that 140R, we're going to show you what a high impedance ground neutral system looks like, and we're actually going to draw one of those in place.
Dude, that'd be awesome. The one that I worked on, can you guess what the ampacity was on it? On the NGR?
Shit, I have no idea. It depends on what was there.
It was a 4160 1200 amp, and it had a 200 amp NGR. And to me, I was like, that thing that's a lot. I mean, 200 amp fault is a lot. You know what I mean? Like, that's where that thing melts.
Mm-hmm.
Like, I mean, and to me, that's crazy to have a 200 amp fault at that high voltage.
You know, and one of the things, when you go in and look at 70E, we actually go in there and discuss this, because this is a type of system that you would use to help clear that fault quickly, which would limit that arc exposure to you.
Right. And that's ultimately what that NGR is doing, is that it's bringing the incident energy out of the gear outside, so that you have that incident energy happens out next to a building versus happening inside the control room.
Sure.
And I was going to ask you too, is the 250 187, is that because the ground's getting murdered? I'm just kidding.
Not exactly.
All right.
All right, well, I'm gonna stop that right there because that'll get me for 4, 5, and 6 next week, and
Okay.
we're already at 1 hour and
All
15
right.
minutes.
And I know nobody's
No,
laughing at my stupid jokes, but
no, we're at an hour and 20 minutes, man. I tell you
uh,
what.
and then we're gonna do code changes because don't you have the things messed
Yeah,
up because you're doing the 5 code changes next, right?
yeah. I'm gonna set that up. Let me go ahead and get that queued up, and I'll
All
go
right.
over the new 5 code. All right. Now, what we're going to look at here is we're going to get into the 5 new code changes this week. And last week we finished up on what 312.10, I think it was.
Yeah,
Is
cabinets,
where
I
we were.
believe. Cabinets.
What we have here this week to start off is we're going to get into 314.5, and this is where we have screws and other fasteners. And this is where they're installed in the field and they enter through the wiring devices. And basically, what it says here is that they should be provided or specified by the manufacturer or comply with the following as applicable. And then they go in, and this is where we talked about this another one, but basically, they were talking about where it had blunt ends and stuff. Remember that?
Oh yeah.
And
Dude,
this
I have this illustration. I have not this illustration. I have this picture. I've installed these.
Yeah, and when you come in and look at this, you'll see it comes all the way 7, and you have the exception here. And all this was really for was adding language here, and it's to protect against damage to the what the conductors, and this is
Right.
resulting from any type of sharp projections that it could have exposure to. That's all this is, and then they also have it set where they also uh, limit the length, from penetrating a certain distance for that application and location.
Nice.
Okay.
Okay. Yeah,
And now,
that's a good one. I don't think that my illustration or my picture would still be a violation.
well,
I
I tell
think
you,
I think we did it. We covered it. One of the myths, I think we did it for my picture was for something about the bringing the neutrals to switch box, I think.
sure, we did, and that'll be interesting. I'll go back and see if I can find that. I know we have a really good illustration that we're going to be showing on that.
Okay.
Now,
No, that's awesome that you have that change in there because it
this
looks like that whole entire thing's a change, and
it is the whole thing is,
yeah,
and it gets into the screw and fasteners, and it gets in talking about not it's having blunt ends and stuff where you don't damage in conductors with sharp objects
right.
protruding out.
Yeah, Willie Jackerson really needs to work on this 314, 16. He is he's packing those things. It's man,
Well, the
dude.
thing I like about this one, what they did, this is box fill calculations, and they added a new item number 6 where they talk about the terminal block fill.
Hmm.
And they're saying if this is present in a box, it's required to have a single volume allowance here. And that allowance is going to be based on what? The largest ungrounded conductor, or the largest conductor, we'll just say, that terminates to that assembly.
Okay,
So you would have to add one more to that if you're doing the calculation with a terminal block in it.
right.
Okay. And
Yeah,
and
that's probably good.
Yeah, and it was just something that needed to be there. And then the next one is 314.23H1, and they added a new sentence. So what they did, they made a revision in this section to clarify that you have a box equipped with a hub shall be made with a listed cord grip attachment fitting that's marked for use with the top threaded hub.
Okay.
So It was just a change just for that flexible cord is what they basically did.
So, is your code change book going to be similar to this?
It'll look exactly like that with an illustration.
Oh, dude, awesome, man.
Yeah,
Dude, I'm
everything.
telling you, you better hit me up when it comes out. I'm sending my credit card number right now. I want
I'll,
I want to I want to be the first kid on the block with one of these.
I'll definitely have it ready.
All
Now,
right.
this is where they're getting into the depth of the outlet and device boxes where you have enclosed devices or utilization equipment, which apparently is an outlet now. Um, but
No,
they,
dude, it's not three-dimensional.
I know. Well, the thing I like, they added here where they did dimensions and depth of, and then they added a sentence here, and basically they wanted to clarify that where you have conductor sizes that are number 12 or 10, that where you're entering from the center portion of the rear of the box, which of course would be opposite to the equipment you're going to install there, that they're telling you you have to have a minimum clearance there that'll be increased to a half inch. In
Oh,
other
wow.
words, you're not pinching
Wow.
those wires, basically, is what they're
Wow.
saying.
Wow. Okay.
Okay, so that
Yeah. What I find interesting is why does it have to say the depth of outlet and device boxes with enclosed devices or utilization equipment? Why do they have to say that? Why?
well, because that's where the equipment is connecting inside that box. That, like I said, that box is what? An outlet.
Yeah. I mean,
That's what I'm trying to say.
why
It,
do they
it,
have to mention both? It's
it's
the
where
same
you're going to
thing.
put something in that you're using or your cord and plug connecting right there at the outlet. And that's what an outlet is.
Yep. I agree.
All right. Now, the fifth one here, change for tonight, is they're going to talk about the clearances where you have side wiring entrance here.
Hmm.
And basically, they're addressing in this change here protection techniques where you have devices or equipment that's mounted in those boxes and you have a side wiring entry. Now, the protection techniques that they're going to talk about here, this will also include the rearward projection of the device or equipment, and it'll tell you it shall not extend beyond the center line of the wiring knockout or other entry. That
So,
that's
so
interesting.
So is this saying that if you install a box in a wet location, it's got to have a half-inch space off the surface?
That's right.
And then if you're bringing in a wiring method, that's gonna have to be rated for wet location too, right?
That's right. Any of it. And that's going to be an out box that's there. And they got clearances now and they don't want those wires being pinched is basically
Wow.
what they're saying.
Okay.
And they're also telling you that when you look at that and they're talking about where you're coming in to the side wiring entries there, that applies to any wall of a box other than the one opposite to the opening.
So if you have your enclosure that's a half inch off the surface, then that would mean your raceway would have to be like 1 inch off the surface or something.
No,
Like,
no. The what they're saying is that the uh, uh, where you have the installed device or equipment that it shall not be less than a half inch from the back of that box.
oh, okay. I got you. I got you.
Yeah.
I was talking about how the box itself has to be a 1/4 inch off that
No, that has
surface.
nothing to do with this. This is for the
Oh,
device inside.
okay.
Eh,
This is gonna be hard for some of those USB devices
Yeah,
because
and
the
if you
USB
look at
devices barely fit in the deepest box you can get.
That's right. And if you look, they talk about that rearward projection of the device or equipment. It says it shall not extend beyond the center line of the wiring knockout or other entry.
Oh, for energized
Yeah,
parts.
that's right.
Okay. Oh,
Those
wow.
those are big changes right there.
Yeah.
And that's
Wow,
why
I'm sure glad they apply to AC units.
Well, that's why I wanted to go through that. There, and if you remember, we were taught, was it 2-3 weeks ago? I said, wait till we get over wiring methods. There's some stuff over there that's going to deal with those devices and the outlet itself that you're going to have clearances. That's going to be something new that the manufacturers are going to have to make sure those devices and boxes match up.
Yeah, absolutely. That's
Yeah.
awesome.
All right.
Yeah, and over here in Colorado, we don't use the 1900, but yeah, thanks for joining. And the 1900 box is basically what we call the Foursquare here in Colorado.
Right.
But and
When
yeah,
I was coming through the trade, we always said 1900 box too. I'm with you,
yeah,
brother.
yeah. We never use that, but I've actually told guys on the job, like right now we're using up some 1.5-inch boxes, some shallows, and I was like, I just only use it for smoke detectors, I was like, we don't use it for nothing else. But all these guys are like, why would you order these? I was like, I don't know. I wouldn't. I mean, I was like, nobody should order the shallow boxes. I think they don't even belong on a hospital job, a commercial job. I don't even. It's just a waste of time to try to find out where you could use them, where you can't use them, and
Sure.
I mean, yeah, you could have a, in and out, or whatever, and it kind of goes into that question that one of our listeners had, and we really appreciate watching our stuff. Mike Kozlov, a good friend of mine, and he's like, yeah, this foreman said that you can take every single knockout out of a box, like it's only allowed a certain amount of. Well, no, you could. In that case, you could take a shallow, and you could run 3, 4, 3/4. I usually use that as a standard, no more than 2 in, 2 out, or whatever, no more than 4 3/4.
That's why you come to the High Voltage Live podcast.
Yeah,
And
that's
learn
what
all
I'm
this
saying.
stuff, brother.
That's what I'm saying. I usually use that as a rule of thumb. No more than 2 in, 2 out. But
well, doing the code changes, I think a lot of people are really enjoying that because we actually, I know Mike did them over at NEC Live, but I mean, we've probably spent, God, I bet you we've spent probably 15 hours already on them, and he only spent maybe an hour and a half on all of his.
he had to blast out. He had to blast out of Chi-Town. All right, brother. Chi-Town out
That's
there.
funny. All right, let's do tool of the week. You ready, brother?
Yep, let's do it.
It's time for Tool Review of the Week. Sponsored by Electricians Only Tool Review and Nipex Tradesman.
All right. So, really great tool review for me is the Ideal Black Iron, and I threw a few little box offset or few little offset multipliers in here if you guys want to check them out. Cool. What we always use as electricians is we use the 30-degree multiplier, which is the ×2, and that's just a common thing. Typically, you don't want to put a whole bunch of offsets in your pipe because what's going to happen is you start adding degrees. And the job we're at right now, we're at 270. We can't exceed 270 without doing a box, the job that I'm at right now. So that's a job spec. That's not the code. The code says no more than 4 quarter bends per wiring method, per between pull points. So a pull point is not necessarily a 1900 box, as Mike mentions, but what we're doing is we're going to pull point to pull point. And so if you go and you put more than 360 degrees, that's going to make your wire really hard to pull. I know a lot of guys tell me, you know what, Willie, we could go 420 degrees all day. And I'm like, dude, if you go 420 degrees on a pipe run, it's going to make it really hard to pull. So, try not to do that. I don't think an inspector will ever really bust you for that, but I would not. I always say you pipe it, you pull it. So, that's the thing right now, what we're going into, when you're doing like a saddle, like say you're doing a 3-point saddle, what you want to do is you want to do a 45-degree right at your obstacle point and allow for your shrinkage, which your shrinkage is going to be 3/16 of an inch per inch rise of whatever you're doing. So if you're trying to do a 45-degree and you're trying to do a 3-inch rise, then that's 3 times 3/16. So there's these multipliers in there. If you want to do a 30-degree, if you want to do a 30-degree offset, and then you want to do like a 10-degree, then you're going to do 20 inches between your marks. And so typically, if you want to do like a 10-inch rise, you want to do like more of a extreme angle, which is like more like a 45-degree. Because if you do a 10-inch offset and you do it in 20 inches, it's going to take way long for that offset to happen. So a lot of times when we do these offsets, we want them to happen fast. I typically use 45s, but you have to keep in mind, you have a 45, you have another 45, now you have another 45, now you have another 45. You have 180 degrees in a 4-point saddle. So now you're limited to, at my job, you're limited to one more 90. And then you have to hit a box. So a lot of times that's what's cool about when you're doing like a hand bender like this. I really like the black iron. I think it held up really good to the abuse. I beat the tar out of it. And it's always accurate. I put the ideal up against any bender out there. I think that's for hand benders, probably one of the best hand benders they make. I know now Klein is coming out with a black iron bender, and I would like to test it. I would like to try it out. I've had bad luck with Klein benders in general, but it wasn't the black iron, so I can't really say.
Well, if you like the black iron, you like it.
Yeah. It's a good bender, and like I say, if you guys want to hit me up and you want me to do more bending tricks for different stuff, dude, Willie Jackerson has so many tricks, and that dude is just. So what I used to always do, but when I was an apprentice, I'd go up to a journeyman, I'd be like, "Hey, can you show me a trick?" And they say, "Yeah, what do you want to know?" I was like, "Dude, I don't know how to do this." And they'd be like, "Well, what do you want to know?" I'd be like, "Well, I just want to see a trick." And they'd be like, "Oh, yeah. What you do is this is."
That was an accident.
Oops. And so what you do is, as James Stallcup, as a little trick, you just freaking play the intro and you throw me off, whatever. But anyway, so I see all these different tricks from all these like seasoned veterans, and they'd say, "Oh, what you do is you get some jack chain, you throw some jack chain in there, but you got to get past the insulation, And so it was funny. You'd love this one. So I was out this elementary school, and we're taking down these lights. They're held up with this jack chain that's like 1940s, like it's almost like toe chain, but it's jack chain, but it's real small jack chain, but it's heavy. And I saw it and I was like, ooh. So I put together my own jack chain, and it can go through anything. You could just pop a hole with your hammer and cinder block, put that jack chain in there. That thing's going to go right down there. You freaking hook the MC cables up there, pull it right up there. Dude, you could use it for anything. You put it in the wall. Everyone's like, "Oh, insulation." Dude, it'll go right through the insulation. Get down there. You freaking hook it up there. Boom. I mean, and so there's little tricks like that I learned, where like people are like, "Oh, yeah, you use jack chain." I'm sitting there with this like light jack chain, trying to get this light jack chain to go in there. And it's just sitting on top of the insulation and just stay there.
Mhm.
And so then I see this 1940s jack chain. I'm like, ooh, that was before an outlet was a thing. You know what I mean? I'm like,
Right.
put it in there, and I mean, it just pushed right through the insulation and just went right down there and hooked it up. Boom, pulled it up, and like, dude, my boss was like, "Where'd you learn that?" You know what I mean? I was like, I just learned it was a trick. It was a trick on a trick on a trick, you know.
Right.
And that's the thing. It's like the heavier the jack chain, the better it is to go through insulation.
Sure.
Now there's times before where I just push a ceiling wire up there. And I could almost sometimes get the ceiling wire to come right out the hole.
Right.
And then hook it up there, pull it through, you know, and everyone's like, "Oh, dude, I just bought this." Well, I think we did a tour review on the glow rods, and the glow rods are great. We use them every day, you know, but you know, sometimes they won't turn or angle or do whatever you want to do. So the tricks are awesome, and I really appreciate all the members of Nat King Code, all the followers of Nat King Code, all the followers of the High Voltage Live podcast, all the members of NEC for Dummies. I created NEC for Dummies because I wanted to participate at a high level in the industry. That's what I wanted to do. I didn't care about all this name calling, all this stuff like, you don't listen to us, you don't listen to our experts, you don't listen to this, whatever. I don't care. I could care less. You know what? To me, the 210.8F was the worst code reference ever produced. It's so bad it takes itself out of the code. That's my saying on it.
Well,
That's what happened. It literally took itself out of the code. It was so bad.
I think 2026 is going to be a very interesting cycle. That's all I'm going to say about it. And
I agree.
you know, I have my thoughts on it. There's other people have their thoughts. That's cool, but doesn't give you the right to make some of the statements that have been made. I'll just say it that way.
So one of the funny things is we can go through this from a timeline thing. So it got passed. They said this applies to AC units. Okay, cool. Then we're like, we disagree. Then it comes down to like, okay, now you're killing kids. That's false. That's a lie.
That is
Like,
a flat out lie.
no utilization equipment has been killing anyone from leakage current. So
Nope.
number one, busted. You know, now now we have maintenance personnel that's getting killed from utilization equipment. That's why it has to be GFCI. That's false, lie. If you're a maintenance electrician out there, you need to go to your boss and say, I need to be working in an electrically safe work condition. Then number three, end of life now. Now we got end of life. That's 70B, that's maintenance, that's, you know what? There's no reason why AC units are blowing up because they're old or they're rusty or whatever. You know, maybe that unit was rusty. Maybe CMP2 should have went and taken a picture of it and said that it was rusty and it was at end of life and that's what killed the kid. You know, I think it's a tragic death. It sucks, but I'm not buying what they're selling. You know, it's just I'm done with that. It just irritates me. Like they put this code change through and everyone's going to have to pay for it. And that's why all these jurisdictions are saying, no, dude, we're not doing this anymore. I mean, now what's coming next is ovens within 6 foot of a sink, microwaves within 6 foot of a sink, all this stuff. Like now under 2023, it's everything. It's everything on a kitchen counter.
I got news for them. They're going to have some compatibility issues there too.
Yeah, and we're trying to avoid that. Everyone's like, oh, what you guys are doing is bad for the industry. I'm like, no, what's bad for the industry is stuff not working on Class A protection.
That's
you know, it doesn't have to always be Class A protection.
You know, it's been beat to death, but you know, I just sort
sorry.
I just sort of feel 2026 is going to be a very interesting cycle because of some of this stuff and some substantiations that have been made, and I'm going to get clarification on it.
Awesome.
I know exactly how to write the proposals and the way it's been stated, and I'm going to have the co-making panels say yay or nay.
Well,
Basically,
I know you're good friends with Crystal, and it was awesome to have her on. That was one of our best shows, having Crystal on here. So
yeah,
maybe we
we'll
might,
get her on again on something else.
yeah, maybe we might get her on, and it'd be cool if we get Jerry on there, somebody from Code Making Panel 17, or some other people, different code making panels, just to, just like kind of spice this up and go, all right, what do you think? I mean, are we wrong in saying this? Is it we hurting the industry here?
Yeah, we'll get, you know, we'll eventually have more and more going on. There's just here lately, there's just things I want to cover. So,
And that's fine too. This is your podcast, so
uh,
I just want to try to spice everything up and try to do the best we can. And like I say, you've made the Nat King code like better than ever, and like I say, I'm hitting 50,000 every week, like on
gonna be
all
a
these
lot
different
more than
groups.
that before it's all done. And, you know, uh, I, I said this a long time ago. I would have been happy just to get 5,000 by the end of the year. I never would have dreamed it would have popped over 20 under, was it 7, 8 months? We're looking at 20, 25,000 now. It's just, I
Yeah,
just thank you to all the people that supporting
yeah.
us coming on to the groups and stuff. We try to keep everything fresh, updated. I can tell you, coming 2023, I'm gonna have some examples of the illustrations that are coming out, and the courses are gonna be, and they're gonna be dynamite, man. I mean,
Dude, and I really want to thank the Electrical Wall of Shame. I never would have imagined that I had a group that could excel so far beyond my expectations. Like, it was just so cool to make a cool group. Everyone wants to post hack pictures or whatever. I got a special one coming your way from my second year apprentice, and you guys are gonna just be like, "What? That's a second year apprentice," And it's fun to joke around about this stuff and just whatever. Like, we're not putting anybody on blast. We're just having fun. We're not trying to, uh, you know, say anyone's a bad worker. They're got bad work ethic, or you know what I mean. Like, we're not trying to do anything harmful to the industry. We're trying to boost the industry, and we're trying to make it better. And if you guys are out there and you want us to cover something, and you think that maybe somebody's got a wrong take on or something, we'll take it on. We're
yeah,
not scared. We're not scared of the controversy. People can call us all names they want. We're gonna still keep bringing it to you every week.
yeah, it's one of the things I like to say is it doesn't matter what the subject is, what topic. It doesn't matter if we're telling you something. It's not an opinion. We're actually pulling it from sections of the code
Yep.
and basing it on the way we feel that's interpreted. I've seen too many comments that are coming out where they're giving interpretations uh, on something that I mean, really reaching out there. It's just like the one they do point on the wiring system. I've never ever heard that you can't even illustrate it. That I mean, God, I mean,
Dude,
I've heard
dude,
some
we
stuff, but
we
my
did,
God, come on,
dude.
man.
We are the first publication that ever illustrated it. We illustrated it. It's the shamrock with the rainbow over it. I mean, dude, we illustrate. Dude, we did it. We did it. I mean, come
The
on.
magically located outlet.
Yeah, I mean, it's number. Dude, everyone always says, I'll tell all the apprentices out there, I'm always rolling sevens. 7. Like when I actually had a special dice, and it had every number on it was 7. And I'd say, hey, let's have an easy day today. And then we'd roll it 7. All right, easy day. So then I started messing with people, and I started putting different numbers on there so that they couldn't just always win.
Yeah.
Because they thought, oh, there's no way that is, they thought, okay, it's a fake dice. It's just gonna roll 7 every time. Dude, my apprentice rolled 11, and I was like, "Ah, you rolled 11! Oh, we're gonna have a hard day," you know. And it was funny because everyone on the job just started rolling, laughing, you know, because I changed that number out, you know. And I was like, "Oh," I was like, "You rolled the one part that made us have a hard day, and we still had an easy day, you know." But it's that thing when you're doing that preparation with your team in the morning that you kind of like to do those little activities where you're like, "Hey, let's have an easy day today. Let's think about what we're doing. Let's think how we're planning. Let's make sure that we're going to do every step to make sure we're productive today. And
Sure.
let's not have a hard day. Let's have an easy day. Make every day an easy day."
If you can. All right, you ready to wrap up? What are we at? We're almost 153, I guess.
Yeah,
We're going on
almost 2.
2 hours, man. Damn.
Yeah, it's all good. Like I
Just think
said,
if I'd have did the whole presentation.
dude, we still have a bunch of viewers in here, so we really appreciate you guys. You know, like and subscribe, and you know, ring the bell, and it's awesome to
Yeah,
have people that truly recognize that we've been in the trade. We learn from the trade, and we benefit from the trade, and make every day an easy day. That's gonna be my new one.
sure. People in the electrical industry, tell them to come on, join. Tell them to anybody you know subscribe to the YouTube channel. It's growing. I think it's over 70 now, and
Yeah,
we didn't even really advertise that. It just
dude,
people go over and do it.
posted NEC for Dummies, posted Electrical Wall of Shame, posted any of our groups. And, you know, if you want to just post a poll and you want to say, you know what, I want to prove something, go for it.
Yeah.
We don't block you. We don't, well, whatever, you know.
We only block you if you start calling people names.
Yeah,
and trying to trash a person. That's it.
there are rules in the NEC for Dummies, and we have union and non-union people in there, and we like to keep it considerate for, you know, like I say, I'm not going to tell you whether I'm union or non-union, but I don't sway either side. I think we're all bringing money home to our families, and I want to keep it that way. I want to keep the knowledge and the learning like equal, regardless what side you're on. I know everyone would, you know everyone that knows me knows that I like to make fun of certain things on certain sides, but I'm not going to tell you which side it is, and it's a lot of fun
Well, it's like I
us to
tell
learn,
people,
regardless.
I went through the union apprenticeship. My grandfather is union contractor. Uh, I've also been out there. I've gone out and instructor for IEC. Uh, I've done stuff for them. I've done it for ABC. Look like I might be doing something with Faith Technologies. Wait and see how all that goes.
Yeah, I like Faith. They're cool.
And yeah, and I've
I
done
worked
a
with
lot
them
of
before.
stuff for facilities all over the country, all over the world, Dad and I. I mean, we've been everywhere. And, our goal was always to provide the type of training that provided safety to the worker and also personnel that are out there that have to interact with the stuff. And
well, and I thought that was
that's
funny.
Top thing you have to think about.
I thought it was funny when I got accused of working in an electrically unsafe work condition, and I was fired up. I was like, "What?" I was like, "This is a guy who supposedly knows 70E
Or he
and
didn't.
is saying I'm working in an electrically unsafe work condition." I'm like, "Excuse me, mister." I'm like, "We are gonna have a video and another two."
Well, when
because
I got tagged on that, and he's quoting table 130, 11034A, saying that's our
wow.
flash boundary. I was like, you have no idea what you're talking about. That's working.
Dude,
has nothing to do with arc flash boundary.
Dude, in those places where we were working at, there could be an arc flash boundary that is on the other side of that wall.
Oh, sure there could.
Like, it's literally like a nuclear blast. Like, you could literally put a red circle and say, you do not want to be anywhere here.
That's right.
And that's the seriousness of that location I was in. That's why I took pictures of it, because I was like, whoa, this is a cool place to learn, And the 70E teacher was like, if you're standing where you're at right now with those covers off, you're not my friend. You know what I mean? Like, he's like, you are not my friend. I don't know you. I don't want nothing to do with you, you know? And it was funny because that's the way he taught. That's the way I understood his lesson, you know? And I was like, what do you mean? He's like, if you're dumb enough to come over here and pull those covers off with no freaking proper PPE, I don't know you. I don't even know what you're doing, you know? And I like the way he put that. You know, it meant a lot to me. And I didn't know what was going on at the time. I was like, oh, wow, it's got to be a working clearance violation, you know? Like, that's what I was saying. And he's like, if you're dumb enough to walk over here in a restricted boundary and pull those covers off with not PPE, you're an idiot. And I was like, okay, that's how he put it to me. And I was like, okay, I was just trying to learn. But it was so awesome. And Bob Cook was like, he was such a good friend, Lemonhead. He's such a good friend of mine. He's like, dude, he goes, we're going to take some backlash on this one. We're going to get tore up on social media. I was like, dude, we're doing it. And it was funny because I was like, all right, the testing equipment's here, you know, and we come walking in with the testing equipment and like, dude, the whole entire control room just fell over, rolled over, laughing when we walked in that door. It was so hilarious, man. Like, you know, that was our medium voltage testing equipment. So, well, we capped her off at 2 hours, but we appreciate everyone joining us. Make every day an easy day.
Amen. We'll see everybody next week. Enjoy all the good football games this week.
Easy Day Friday.
Hook 'em horns, baby.
Yeah.
Yeah, they got playing Texas Tech. Guns up for them too, but they're gonna.
Dude, don't even get me started on the Broncos, man. Don't even get me. Dude, I never thought that the Cowboys would be better than the Broncos, but they're better.
Well, that's not a big achievement.
Yeah, I'm like, what? Dude,
hey, after the first week, I was saying Cowboys suck. Then they win last week, which they could have done better if they'd opened it up like they did the first half. And now this week, I think they played Monday against the Giants, which is a division rival. If they play like they did last week, I think they're going to beat them. So now all of a sudden, I'm thinking, hey, they got a chance to win the division.
Dude, it was the sorriest win we've ever had in Broncos history. We get 2 delay of game penalties in field goal range. We have to punt. We get we got like the 12 men on the field. It was 3rd and 10. We get 12 men on the field that easily pick up the first down. Like, it was this catastrophe of play calling. But we won. We got the win. But I mean, it should have been like 35-10 if we'd have played a good Broncos game. But I mean, it was like we barely won by a few points. And it's cool. I mean, a win's a win. You know, I'm not gonna go there.
Hey, and the NFL wins a win because anybody can win any given week.
Yeah,
I can't show any given Sunday.
Yeah, Russell looked kind of ruffled a little bit, you know, but and it was against some team from Texas that could be good someday. You know, you never know. So, you know,
did y'all play Houston?
Yeah.
Oh, Houston. The only time I liked Houston, the Oilers, when they had Earl Campbell. Earl Campbell was a freaking stud.
Yeah, I remember the old Oilers.
That was a man right there, boy. I tell you, tackling him, them big ass thighs. God dang.
Me and my brother, when we'd go get the little helmets, the NFL helmets, if it dropped out and it was Houston Oilers, we got the reject. We're like, you know, like we wanted to get something good. We're like, Chicago Bears, you know. And then it's like, Houston Oilers, you know.
I tell you, you know, when you look at the teams this year, it's going to be interesting to see because some teams I thought were going to do real good ain't doing that good.
Dude,
so
Buffalo and Philly, man. like Buffalo looks really good, man. I was like, whoa.
I, I'm not so bullish on Philly yet because they haven't really played anybody.
Yeah,
You
true.
know, the Cowboys actually played two really good teams to
Dude,
start off.
San Fran, like I'm scared of San Fran coming here. Like San Fran looked decent.
Yeah, they got a good team.
Yeah.
And I think every year changes, especially NFL with free agency, everything. And it's going to be interesting. I mean, we ran Cooper Rush out there to play quarterback this last week. And I'm just going to say it. Anybody watching Texas, I think he's better than Dak. There you go. I said it. I think he's a better thrower. I think Dak's too scared to throw it down the field.
We have a funny one that we always do where it's like, all right, Dak, what do you want for Christmas? And Dak says, I want a dragon. And then they're like, all right, Dak, be more realistic. He's like, okay, I want a playoff win. They're like, all right, what color dragon?
Yeah. But,
You know?
it's like for that Tony Romo, he said, I think Rush is going to be fine. And he said the same thing. He goes, he's a gunslinger like I was. And sure enough, he's throwing it down there, you know, 20, 30 yards, making long completions. Very seldom you ever see Dak do. He's always doing the little dump offs.
Yeah, we had a lot of drop passes. Like that irritates you when you have a whole good drive going, you have that
Mm-hmm.
momentum going, and then the receiver drops a pass. That can't happen in
Not at
a
that level.
regular season NFL. Yeah, you can't. Oh, dude, we had one where they went to the Texans went to punt. We didn't even have a punt returner back. We didn't even have a punt returner back to receive it. We had to call a
That
timeout.
that special team coach needs to have a talking to. That kind of stuff shouldn't happen.
Yeah, I've never seen it in my lifetime with the Broncos, but it is what it
Oh,
is. I mean, you guys got a little Monday morning action
yeah,
on
we'll be getting
Thursday.
that going for too long. It's just I'm trying to get everything done. I'll be honest. I've been swamped. I mean,
Yeah.
I was up all night last night getting the presentations and stuff ready, and even
Dude, thank you
for
so
the day.
much, dude. It's awesome. Like I'll tell you what, I was up all night arguing with a whole bunch of people over like different things, and it's funny because it's like, what I've never said I was right or wrong. I'm just saying that this is what it says. This is what the code says, and they're just like, no, it doesn't, and it's like, okay, whatever. This is what it says.
Well, they have their mind made up. We have our mind made up.
Yeah.
I mean, they've been tagging me left and right. I haven't even answered because I've got too much other stuff I was getting
Dude,
done.
I don't even care personally. It doesn't hurt me one bit. Like everyone's like, "Oh, you lost credibility." I was like, "What? As a code-making panel member?" Well, no, you're not a code-making panel member. Okay, why would it matter if I lose credibility? I don't care.
I'll
Yeah.
say one thing that I've been told that, and I'll say this: why is it I'm losing credibility because I believe different than you?
Yeah.
Yeah. In other words, uh, they start all that, and then I just tell them whatever. I just give it right back to them. I'm like, if you want to talk that way, I can talk that way too. You
Dude,
know,
and once again, I want to let people know that's watching this podcast, James Stallcup's credibility is beyond belief when it comes to all these different subjects that we cover every week. And I want to give you the highest praise
well,
of
thank you.
any NFPA instructor out there. I don't know any other NFPA instructor that has higher rankings than you, and your knowledge of the code, why it's the code, the language, and where it is, and how to find it, and the calculation of it, the math of it, theory of it. And I just appreciate you bringing me along, and it's really awesome, sir.
Well, it's like I tell people, you know, just just go look at the publications. I'll show you what we have. If you got a question, and most people, I've had a lot of them like I've never even heard of this, and they look at I've had actually guys that had gone through school saying why didn't we study out of this? this explains it, And I said, well, everybody, what I've learned over the years, you got certain people in position, they got agendas and they use certain stuff for whatever reason. And a lot of times it's not who has the best, it's who you know in certain areas. And uh, that's just the way I look at it. But I've always said this, when they've talked down to me, and saying, your material sucks and all of this, I just tell them, hey, post anything you think's better. I'll let you even pick it and I'll post on that topic. They never do it.
Yeah.
And that's how confident we feel in these publication stuff, because they've been, you're looking at 40 years of adding to those publications.
Well, we all know that isn't a established standard nowadays. 40 years ago, the ground was different, and everything is different 40 years ago than it is now. So, but the thing is that I love the fact how you evolve through all that, through your publications. Like, you're not just taking a publication and selling it to people. Like, you're taking a publication, you're evolving it, you're making it better, and then you're selling the evolution of that. And that's
Right.
what I always love every time that you post. Like, look just right behind you, dude. That's awesome.
It's just
I
like,
mean, you got my motor over there, like right above volt.
well,
Like,
it's
that's
just,
a wedge 9-point configuration right there, and you go out there and pull open a wedge peckerhead, and that's what you're gonna see. I mean, that's awesome. To me, that's awesome.
it's just like you made the comment and you were talking about, we were doing the separate drive systems and we had all the sections there, but under all the different call outs and stuff you look at. I don't ever see any publications that do that. And
Yeah.
the reason they don't, because it takes a lot of time and effort to go back and to update all that, any sections that are changed.
Uh-huh.
And the reason
Well,
we,
and a lot of what they try to do is question banks,
Mhm.
and then that question bank has to be updated. So if you have like 100 question or 200 question or 500 question bank, and then that's under 2017, that thing's junked for 2023.
Oh yeah, like I'm gonna have out as quick as I can. I'm gonna do the journeyman update first and foremost,
Mhm.
and uh, I've also taken and I've added the remainder of other illustrations that are more in depth and detailed for the masters, and I've already pumped up and added in to it an additional 250 questions that are more specialized for the masters. So the masters is going to have 1,000 questions in it, and it's going to have probably around 300 calculations for you to
Wow,
study, and then I'll have 10 practice tests. So
awesome.
it I always tell everybody, most of the journeyman tests that you go and look at, they just ask questions. They're question banks, all and they charge you, you know, what, $400 to 1,000 or whatever.
Well, no, but you get their videos too.
Yeah, well, ours is going to have where you can actually work the calculations online in a step and step format. There will be code loops that you follow,
Nice.
and we've got the answer key with it. And of course, anywhere on the slide, you can click the sections or tables, they'll appear. And then this next cycle, I'm going to add the video with the voiceover, what I want you to know to pay attention to as we're going through it. And that video will be there with the illustration explaining it also. I've never seen any courses out there that have that much detail in them when it comes to prepping for courses.
Dude, you have to get your Colorado, man. Freaking, I gotta get my continuing education done
Yeah,
soon.
I need to call them.
Okay.
Uh, I've got a bunch of stuff. I've got so much going on. I haven't even
Dude,
thought
they
about
said
any
they
of that.
tried to call you twice and they got a busy signal.
Did they?
No, I'm
Uh,
just kidding.
I, usually they leave a message and I'd pick that up. But
No,
anyway,
they just said you were busy.
all right, let's wrap her
Uh,
up.
awesome. No, thanks everyone. I appreciate another great podcast.
All right, everybody have a good week. We'll see y'all next Thursday.
Deuces. Every day an easy day.
That's right.
Thanks for joining, David Engelhard. Thanks for joining, Mike Kudla. Thanks for joining, NEC for Dummies. Knowledge is power. Learners today, leaders tomorrow. Are you ready for the coaching book? Thanks to Grey Boy, Saul Capadina, appreciate you. Thanks to the 2023 Code Ninjas. The NEC Deathmatch, the best competition ever. Thanks to the Lady Electrical Apprentices. Thanks, gals, for joining us tonight. Subscribe, ring the bell, never miss another live. Thanks to Electrical Code for awesome electricians. Thanks to Electricians Only 2, the second one. Thanks to NFPA 17 Instruction Group. Thank you guys. Thanks to Mark Campbell, Electrical Energy Estimating. High voltage electrical means. Thanks. Hope everyone enjoyed the podcast. Thanks for joining tonight.